can tolerate an enormous amount of heat when we eat properly and eat in alignment with our normal physiological structure. Now let me tell you about heat and the melanin molecule. Carol Barnes writes a lot about this. This is how he got interested in doing the research on melanin.
Training continued. The engineers constructing the shuttle were desperately searching for a material that would protect the ship from the extreme heat of re-entry over and over again.
It was a lot of stress. We were working 68 hours a week, all the time, out for a long period of time.
After many failed attempts, Tom Moser and his team finally manufactured an exotic compound of pure silica glass fibers. Silica's chemical composition absorbs heat extremely slowly. So slowly that during re-entry, it was calculated the temperature of the shuttle's aluminum body could be kept under 348 degrees Fahrenheit. But there was a problem. The silica tiles couldn't be stuck directly to the aluminum.
We developed this thermal protection system, tailored it properly, but with the aluminum expanding and contracting a lot, and the tile not expanding and contracting hardly at all, going through the temperature range, we had to isolate the tiles from the aluminum structure.
A solution to the problem was found in the most unlikely of places.
We used a felt material. It was the same felt material that you make Stetson cowboy hats out of. So it wasn't exotic. We didn't come up with any new material.
The felt was stuck to the aluminum, and the tiles were stuck to the felt. And the glue they used could be found in every home in the country.
Well, the adhesive that we use is bathtub caulk. Same thing used around the bathtub. It's a rubber. So using bathtub caulk and cowboy hat felt, we would attach this new, sophisticated, newly developed material to the aluminum structure. Lo and behold, you have a thermal protection system.
The team made 25,000 silica tiles and covered the vehicle.
So it was that kind of engineering problem that we came up with a unique solution to it and fixed the problem and didn't add a lot of weight to the vehicle.
He was given an assignment to find out what he could do to insulate the wiring of a high projectile object so that it would not short-circuit electrically while going through space. This was a project that his company he worked for was being contracted by NASA to figure out. If you remember the Sputniks and all these other objects they were projecting in outer space, they all burn up before they could get out of the stratosphere. And the reason why is because the electrical wiring would set the object on fire. Because when it would go through space, the friction would overheat it and it would actually start a fire. So their thing is like, we gotta have a means of communicating with this thing. It's gotta have electrical wiring, but how can we get it through the stratosphere to outer space and not burn up? So again, because they've been doing research on melanin since the 1700s, they knew that melanin had a wonderful capacity. That it could be exposed to high temperatures and actually drop the temperature by 50 to 60%, even though it was exposed to high temperatures, and maintain its normal metabolic functioning. So they have found out that the melanin molecule can be exposed to up to 1,500 degrees of temperature and only lose 50% of its normal functioning. And that it also can drop the temperature after exposure by 50%. So therefore, Carol Barnes and his company made synthetic melanin, incorporated it into the rubber that enclosed these electrical wires, and that's how these objects are now being able to get out of space, because they are all insulated and lined with artificial melanin that covers the wiring system. So then that really says something about you then, because now here you are, it's only 92 degrees outside. And you have a substance within you that has the capacity to absorb heat and dissipate it so that you don't even get hot. Why would you be fanning, and why would being in 90-degree weather be a problem for you? Normally it wouldn't if the melanin was functioning properly, or if you hadn't put something in your body that caused the melanin to get overheat.
Fighting a fuel spill fire using a hand line is very dangerous. There's a point when the heat gets into the bunker gear, you'll feel it directly. It protects. From the beginning, you couldn't feel anything. It gets warmer and warmer, and then at one point, the heat is going to get directly inside the bunker gear. And this is a critical situation.
The bunker gear is made from one of the strongest materials in the world. It needs to be. Human skin starts burning at just 120 degrees. The suit weighs 8 pounds. The key material is PBI, a substance used in NASA spacesuits. It's mixed together with Kevlar, a material used in bulletproof vests to produce a strong, heat-resistant surface. Even with the bunker suits, protection is limited. The material is tested to withstand the heat of this 1800-degree fire, but the test only lasted 8 seconds.
This is really important for us to know the limits of our bunker gear before we go into a real scenario.
Interesting. Exposure is all over this thing. I'm talking about exposure in so many ways. This silica that they use is from the earth, they said, and we know that silica is used for hair, skin, and nails. And the universe has placed hair, skin, and nails in a tropical environment or where it's hot. And the type of hair, skin, and nails is the people with the color in their hair, skin, and nails. They're the happy, nappy people. So that is there. Or the diabolical process in which they got the so-called melanin and placed it on the craft as it moved from one climate to another, the climatization. And the heat is distributed evenly in those pressurized moments. So maybe they can't admit to that occurrence going on. So that's very interesting to say how and what is going on here. And also to say carbon in opposition to melanin is a balancing act as well, with balanced people, both parents, the universal order. So I'll add that in there to bring that to life as well.